Question 1. A man of mass 70 kilograms stands on the floor of a lift which is moving with an upward acceleration of 0.3 meters per second squared. Calculate the magnitude of the force exerted by the man on the floor. So as with any force question, the first thing we should always do is draw a diagram. So there's the floor, and here's my man standing on the floor of the lift. And he has a mass of 70 kilograms and an upwards acceleration of 0.3 meters per second squared. Now let's put the forces on. We've got a downwards force, which is the man's weight, and that's going to be equal to 70 times g. Remember, the gravity constant g is 9.8 meters per second squared, and that's the acceleration due to gravity on any body that's in free fall. So we've got 70g going down, and we've got a normal contact force going upwards, which we'll call r. Now, because there's an acceleration, these two forces won't be equal to each other. So over here we're going to set up our force equation, and it's going to be of the form F equals ma, where F is the net force and this is just mass times acceleration. So taking upwards to be positive, we do that because the acceleration is going upwards, and we've got a force r that's going in the positive direction, so we'll put that here. In the negative direction, we've got a force of 70g. So we're going to put minus 70g because that's in the negative direction. And that's going to equal mass times acceleration, which is just 70 multiplied by 0.3. Simple bit of rearranging, we'll add 70g over to the other side, and we'll get 70 times 0.3 plus 70g. And we'll put that into our calculator. And we get 707. And that's a nice straightforward question just to get us started on the exam by applying force equals mass times acceleration.